Welcome back to another stream. There's a new game today. I found a game called The Farmer Was Replaced. Seems kind of interesting. It's kind of an idle programming game. At least that's the gist I'm getting. You're supposed to program like a drone that farms for you. I haven't even played it at all, so this is gonna be a first impression of the game. But yeah, I changed my setup a bit as well. But it looks like the game audio is coming through. So without further ado, let's start. Okay. Getting started. This window contains information about everything in the game. You can move windows around by dragging and dropping the gray part of the window. You can move around by dragging anywhere outside the windows. Interesting. To get started with programming, go to the first program page by clicking it. Be sure to check out the buttons in the top right corner of the screen. Hover over them to see a tooltip explaining what they do. One of them opens the tech tree. Okay, so open to unlock the tech tree, open a new info window, and create a new code file. And we can also move around these windows. Can I zoom? I can zoom. Okay, nice. And this has to be the program window. So to get started with programming, go to the first program page by clicking it. Okay. First program, text editor. All programming is done in code windows. Each code window corresponds to a text file containing code. You can rename the file by clicking on its name at the top of the window, like this one here. Can call it something else, but let's keep it at main. The code can be edited like in any text editor as long as it's not running. You can execute the program directly by pressing the green play button in the code window. The green play button, is this the executes one step of the code? Okay, so it's not the and this is the start and or stops execution of the code in this window. You can create more code files using the plus button in the upper right corner of the screen. You can dock a window to another window by dragging it onto it. Okay, so not like that though. But maybe I can dock. Oh yeah, I can dock these windows. Okay. Remove that one. You will notice that once you start typing, a simple code completion window will pop up. Press tab to insert the code completion. Use the arrow keys to navigate through the completion options. Don't worry if this is your first time programming, the language is unlocked step by step, so you won't be overwhelmed by all the things you can do. So yeah, the language seems to be a custom one, just for this game, but it's supposed to be kind of like Python, if I understood it correctly. Which is great since I'm learning Python in the AI dev stream. Hopefully it won't confuse me. The syntax is also similar to that Python. So yeah, I skipped over that part completely. Which is one of the most widely used programming languages in the world, so learning it is not completely wasted. If you already know Python, it's not a problem either. You'll just be able to skip the early game quickly to get to the more interesting stuff. Currently, there are two drone commands available: harvest and do a flip. These are function calls. You can think of a function as a command that can be executed. You execute it using the parentheses. Try typing these statements in the code window and pressing the execute button. You can think of your code as a sequence of statements. You can run multiple statements in a row like this. Okay. So let's try, move my keyboard over a bit, and then harvest, and do a flip. And then we can run them. Oh, nice. And can do harvest again. Why not? So, oh, and it's a really quick one on the regrowing part. And we get 5 hay. Okay. Unlocks. Collecting grass will give you hay. Hay can be used to unlock loops in the unlock menu. Open the unlock menu with the button in the top right corner. So this one here. So, oh, it costs 5. That's convenient. So while true. It looks a simple while loop. Okay. So now we have the while loop. You have unlocked the while loop and the values true and false. The while loop keeps executing the loop body as long as the condition is true. While condition loop body. Don't worry about creating infinite loops. The delays in execution will prevent the program from freezing. For beginners, perhaps you have already tried to put several harvest calls in a row. Kind of. This allows you to harvest several times in one program run. However, it would be nice to harvest more than 3 times, and writing the same code multiple times is bad practice. The solution is a loop. A loop allows you to run the same code multiple times. The while loop takes a condition, which is a logical value that can only be in one of 2 states, true or false. Such a value is called a Boolean value. The loop then executes the code inside the loop until the condition is false. The while loop looks like this. While condition where you have to replace condition with a Boolean value and the loop body with whatever you want to do in the loop. There are 2 constant Boolean values available. Constants are values that never change during the program. To create a constant Boolean value that is always true, you can simply write true. Write false as a constant Boolean value that will always be false. So you could either write while false, do a flip, or while true, do a flip. The first will never do a flip, and the second will do flips forever, an infinite loop. Normally creating an infinite loop is a bad idea, because it will freeze the program. But in this game there are delays between each iteration of the loop, so it will cause the drone to keep doing flips until you manually stop it by pressing the execute button again. Notice how the line after the colon is indented. Indentation like this is used to separate blocks of code. Just press tab to add indentation, shift tab or backspace to remove it. The loop will repeat all indented statements after the colon. Statements after the indented block will be executed after the loop has finished. Ooh, okay, that's a lot of reading. So, to get some easy harvesting done, we could simply do while true, and then we could indent it like this, and then we can run it. And now we have infinite monies, infinite hay, infinite gains. Okay. And this is the end of... wait, oh, both go back to the table of contents, so I could simply go back here. So this is kind of like the tutorial window or whatever. Items, hay, entities, grass, ground, grassland, and soil. What is soil? Calling till turns the ground into soil. Calling till again change it back to grassland. Okay, so we could... if we do till here, then it will change back and forth. Error, cause a runtime error. Unlocks.carrots must be unlocked before this can be used. Okay, that's kind of fun. Let's do harvest then. And keep gathering hay while I read through this. And grassland is the default ground. Grass will automatically grow on it. Do we have any? Pet the piggy. That's the piggy. This action is not affected by speed upgrades. Returns none. Takes 1 second to execute. Okay. Oh, this piggy here. How do I pet the piggy? Okay. Can I do infinite flips? I wanna try. Do a flip. Yeah. The sound design is kind of like, I don't know, ASMR like for some reason for me. I don't know. Okay. My guess is that you're supposed to keep harvesting while buying more stuff. Okay, hats for your drone cost 50. Speed increases the speed of both the drone and code execution. Increases the yield of grass. I suppose some speed. Okay, speed upgrade. The execution speed has been doubled. The problem is that the drone now harvests faster than the grass can grow. Ooh. Faster than the grass can grow, resulting in no harvest at all. To deal with this, if branches and the can harvest function are if branches and the can harvest function are now unlocked. Check before harvesting. So far we only had true and false conditions, which is of course not very useful with if. The new function can harvest produces a better condition. Can harvest returns true if the plant under the drone can be harvested and false otherwise. So if can harvest, do something. The reason you can use this function as a condition like this is because it returns a boolean value. A return value essentially means that after the function is executed, the function called expression evaluates to the return value. I don't know why, but my brain's not computing this sentence. A return value essentially means that after the functionality is executed, the function called expression evaluates to the return value. I'm not totally sure what this sentence is getting at. What happens when the above code runs? The if runs, can harvest is called, can harvest does its thing, can harvest returns true or false. The statement is now if true or if false. The code block is only executed if it can harvest. Oh, it's a an explanation on the return value of the function. Okay. Now we can use if to prevent the drone from harvesting too early. That all makes sense. So instead of using while true, we could do while can harvest, because this function will only. Well, or wait, can you do that? No. While true, still while true, and then we can check if can harvest. Like that. So we do an infinite loop and we check each loop if we can harvest, and if we can harvest, then we do harvest. Wait, oh, the colon. Nice. And that's it for that explanation. So expands the farmland and unlocks movement. That's probably more interesting than increasing the yield. Okay, expand 1. Your farm has grown. This space is not much use if you can't move the drone. So there's a new function called move that moves the drone. Move requires that you specify the direction in which you want the drone to move. There are 4 new constants for this: north, east, south, and west. For example, move north will move the drone 1 square to the north. If you move over the edge of the farm, the drone will be moved to the other side of the farm. Oh, so you can kind of speed around if you have a really large farm or something, maybe. The following example code will keep moving the drone north and wrap back to the start when it reaches the edge of the farm. So I suppose you could do if can harvest, and otherwise move north. So we will always move north on each loop and only harvest if we can harvest. Then if we were to wait, then if we were to increase the speed, wait, unlock cost. Okay, we can't. We need wood for that. I thought we could like increase the speed like enormously and just have one long strip, like that, and have the drone like all the way up, but that would be too easy probably. So what's the next step here? Plant unlocks planting. It's probably a better idea to increase the yield first, so we can get double the hay. I also want the hats. Yeah, you have unlocked a few new hat colors for your drone. Equip them like this. Wait, can I? Yeah, I can copy and paste. Nice. Wait, I could change the hat by doing like change hat, brown hat, for example. And then when I run it, now the hat gets changed. Okay, nice. Wait, this can keep going. And we need to do the plant. Unlocks planting. Plant. Grass is nice because it grows automatically. All the other plants have to be planted with the plant function. The only plant you can plant right now is a bush. You can pass the type of plant you want to plant to the function like this. Plant entity.bush. This will plant a bush under the drone. Call clear to reset the farm to all grass and reset the drone position. In case you fuck up or something. Maybe. It seems that if you grow more than one type of plant on the farm at the same time, you can sometimes get a higher yield. You need to research polyculture to learn more. Okay, so like having a variety of plants will give you more of the plants, is my takeaway. So I suppose I could call them plant. Was it plant.bush? No. I forgot about the plant entities.bush. Plant entities.bush. So now we'll get one bush. But this one will only... Yeah, and it goes back to grass afterwards. So... Can I somehow get the entity... Like if... harvest. No, let's say if can harvest. Then check again if entities.push. Then harvest plant else harvest probably. So if we can harvest whatever is under the drone, if it's a bush, then we harvest the bush and we plant a entities.bush. Otherwise we simply harvest with need to a colon there, I think. Oh yeah, and here as well. Maybe. I have no idea if you can use an if statement like this, but let's try. Plant a bush, and it plants a bush. Why? It checks. Wait a second now. It checks if we can harvest it. Then it checks if it's a bush. If it's a bush, then we harvest and plant the entity.bush. Otherwise, we're supposed to simply harvest it. Oh yeah, we should also do a clear. Now say here's a perfect place to do a clear, I think, because then we can, yeah, we can replace that one. But it seems like the if statement, if entities.bush, will always get called. Or am I wrong? We're never calling harvest, are we? No, we're simply jumping over harvest. So I suppose we can't use the if statement like that. If. Else if, else if, else. Okay. A wood bush grass. I can see no clear way to check what's under the drone. You forgot the space on a second if. I did? Where? While true. So it's indented here. So this is inside a while true loop. And it's indented inside if. So if we can harvest, then we run this one or this one. Right? I don't know, you might have more knowledge about Python or similar languages than me, but shouldn't this bond be nested inside this one? It's simply confusing because this one always gets called, I think. Because when you start it, now we have entities grass. Or wait, are we supposed to check if ground? No, we can't check ground. What can we check? We can check entities. Entities dot push. I don't know, I feel stupid. Can you explain more, Emdernas, what you mean by this space on the second if? Oh my god. Is it simply this one? No, it can't be that simple, can it? No, it still isn't getting... There might actually be a... Wait. Get cost, unlock. Trees is speed. Simulate. No, there should be... I don't think you have unlocked the upgrade to check the tile under you, because just typing if entities.bush checks if entities bush exists. Oh, okay. Okay. That makes sense. So I can't split the farm in this way. Or there should be some way to split the farm, I suppose, but it might be easier to simply... Let's farm some more wood. Now I have 22 of them. Might be worth it to expand. Yeah, that has to be the most worthwhile thing. Your farm has expanded again. Now the tiles are no longer in a nice row, so you need to find a way to traverse a square grid. With the while loop, this is not possible until you unlock senses and operations. It is time to introduce the for loop. You can read all about the for loop on the for loop page, but for now you will only need to repeat code a fixed number of times. So for I in range 5, do a flip. So you do 5 flips. Range and creates a range of numbers between from 0 to n-1, which has n elements in it. The for loop runs its loop body once for every element in the sequence. In this example, do a flip will call 5 times. The function getWorldSize is also available now. It returns the side length of your farm. This way you can write code that won't break the next expand upgrade. For I in range getWorldSize, harvest. So that will move myself north 3 times. Okay, so let's do it like that. You need a census upgrade to split the farm. Okay, yeah, it mentioned something about census upgrade here. Somewhere. But I shouldn't need that one right now. I'm just gonna hide this one for now and try to work this out myself. So while true, for I... Wait, I've already forgotten the the way to write it. Okay, so there was no for I in range. Okay, get world size, get world size. Like that. Then harvest and move north. And then we can also, can we simply copy and paste this one? Yes, nice. Move world size minus, or wait. We somehow need to reset our position as well. Because if we start here, then we're going to move too far. But without census, then that's a... Suppose we could do move north. Oops. And then maybe comment out this here. And then... Wait, clear. There was something about clear. Did that reset the board completely? Clear. Removes everything from the farm, moves the drone back to... Okay, so we can simply do clear. On each start. Clear resets the position, yeah. Thanks. So... Wait, can we do simply the east like that? Let's see what happens. Wait a moment. Let's remove this one here, it's confusing me a lot. So if we start from this position, then we should go... Where are we going? Oh, that's right. So we should go... -1. Wait, we can't do... That's correct. We need operations, arithmetic, comparison, and logic operations. So we actually have enough for this one. So let's buy operations. Arithmetic operations, comparison operations, Boolean operations, not and or, not all numbers in the game are floating point numbers, so all arithmetic operations are floating point operations. Double slash is defined to just floor the number after the division. For assignment operations, you need to unlock variables. Unlock. I don't think I need to read all of this. I should simply be able to do -1 like this, right? Yeah. Nice. And this is actually working. I didn't expect it to work like this, but I thought I'd have to go like in a, I don't know, in a circle, whatever you call it, in a spiral, and then clear it again to restart. That should be the most efficient way to farm this size, though, I think. Because now we're going back to this position a bunch of times. So let's try doing that. So wait, so we need to do -1 as well. So if we were to do like this, then we'd go into, and I shouldn't have paused there. I need to see what happens afterwards. This is pure chaos. So afterwards, we loop through get world size -1, and we harvest, and we move south. And then for I in range, get world size -2, harvest, move west. And for I in range, get world size minus, should be -2 as well, since we already did the top. And harvest and move north. This is a very ugly way to do it, but it should work. Wait, clear. Can't you put clear? Expected a comma or closing bracket. What? A comma? Like that? No, man. Oh, okay, move north. No. And when range. All the typos. Where did I miss? Wait, is it gathering? No, it's not gathering that one. But why? Is it too slow in the harvesting? Maybe? I don't know, man. But you should be able to do harvest and plant entities bush. Then we'll get 3 bushes and they should wait 2 bushes. Oh wait, it's because we're harvesting and then moving. No, wait a moment. So in the first loop, we harvest, then we plant a bush, and then we move north. And then we harvest, and we plant a bush, and we move north. And then we don't do anything in this loop. We need to check, like, if I equals 3, then harvest and plant entities, a bush. This feels illegal somehow, but it should work. No. I equals 2. Am I wrong? My bad. Equals 2. No, wait. I start at 0. So 1 and 2. Is it the operation sign that's wrong? No, equals. I should be 2. Wait, there is a print function here I can buy, and I have enough. Okay, debug. Sometimes your code just doesn't work and you need to find out why. Perfect timing. There are a couple of tools to help you do that. The first is to execute the program step by step. You can go into step-by-step mode with a button next to the execute button or by setting a breakpoint. Oh yeah, that's right, this one. I forgot about that one. I kept pausing, but I could simply... So clear. Wait. Not on my I is equals 1. Alright, I'm lost. Let's continue with this one here. Breakpoints can be added by clicking the breakpoint panel to the left of the code. So here, okay. When execution reaches the line where the breakpoint is, it will automatically switch to step-by-step mode. When you move your mouse over a variable, its current value is displayed. The print function can also be very useful. It will write any value passed to it directly into the air. Examples: print true or false, print the current position. Okay. The print function prints the value directly into the air and to the output page. Okay. Oh, now I lost this one. Where's the debug here? Writing into the air can sometimes be a bit slow if you want to print a lot of values. In this case, you can use the quick print function, which prints only to the output window. The output window also logs warnings and errors, so if something doesn't work as expected, it can be useful to check that. When execution stops, the output is also written to the output.txt file or output.txt file in the game folder. So, oh, it's an actual an actual file. Interesting. Okay. So I could do, if I were to do print I, and if I were to run it, then 0, 1. Is it because we go from the 0 position and we do a harvest, plant, and then we move, and from the 1 position we do a harvest, plant, and then we move. But we only do those two. I suppose that makes sense. There has to be a more efficient way to go through this. Can you go... You can't go to a position, you can simply move in a direction. Is there a move here, move built-in function? Returns true if the drone has moved, false otherwise. Okay, so we can check if it's been moved. Can harvest. Range. String object. Returns a string representation of an object. Takes 1 tick to execute. I don't know, man. There should be a better way to do this. Because this feels very hard-coded. But I suppose it's the sensors I'm missing. If there even are sensors. Can't find it. Random functions. Lists. Oh, here is the sensors. Okay. The drone can see what's under it and where it is. So this is the one I need. Okay, this should simplify everything a lot. The drone can see now. The function getPosX and getPosY returns the current X and Y position of the drone. At the start position they are both 0. The X position increases by 1 every tile towards east. And the Y position increases by 1 every tile towards north. Num items. Item returns how many of an item you have. For example, num items.hay returns how much hay you have. Get entity type and get ground type returns the type of entity or ground that is under the drone. Do a flip if you're above a bush. Okay. The none keyword is also unlocked now. None is a value that represents that there is no value. For example, a function that has no return statement will actually return none. Get entity type returns none if there is no entity under the drone. If you want to find out how many of a particular unlock you have, use the num unlock function. For example, num unlocks.speed will return the number of speed upgrades you have. Num unlocked senses return 1 if senses are unlocked and 0 if they are not. You can also use num unlocked on items, entities, or grounds. This will return 1 if it is unlocked, otherwise 0. Be careful, num unlocked.characters will return the number of times it was unlocked / upgraded. Num unlocked items.characters will only return 0 or 1. Oh, unlocks carrots, okay. But items.carrots will only return 0 or 1. Okay. I feel like I want to increase the volume a little bit. There is no music, but there's some bird song and stuff like that. Okay, so I think it's best to simply delete all of this and start from the beginning. So we clear at the start. Clear. And there we go. So we want to have a loop so we can keep on farming forever. And then we also want to move. So for I in range. Wait, what something world. Get world size. Get world size. Or wait. We'll simply repeat the old programming now. And I could check if get pos y. Is that a function? So if that's equal to, or is it if it's less than 2, move north. That will move it to this position. L if, so if it's not, then get, wait, otherwise, No, I can simply do else. Then we want to move north and move east. And this should have us loop around it, shouldn't it? It isn't really that efficient since we're going back. But I say it's good enough for now. And we do this on each loop. We can also check if get was y. If that is equal to 0, if we're on the first row, then we want to plant the bushes, I think. So if can harvest, then we do harvest and plant. Entities, dot bush. Can't forget the colon. And otherwise, we should say else if get ground type equals what was the ground types? There was something about the ground types, grasslands or soil. So isn't grounds dot grasslands. So if we can't harvest but it's grasslands, then we want to plant the entities bush. Then we want to plant the bush. I think. Now we should be able to simply plant and farm this section and while not touching this section, I think. Wait, error. Ooh. That. Let's try it. Oh, wait. Am I stupid? I'm stupid. I meant to say is if pos x equals 0. I don't know why we missed that first one. Oh, we missed that first one because we move after we do the check. Okay. So we should really do this beforehand. So we start by checking our exposition and the harvesting and all of that. And then we move. So like that. Interesting. We should also be able to maybe, unlock the speed so we get more speed. Now we're even faster. but we're too fast. Well, too fast for this. Also need to harvest the this one as well, the hay. Or the grass. So if we're on, we should have another else harvest, I think. Or no, if can harvest. Harvest. I think. And now since we're pausing at each step and harvesting, then we're actually timing the growth cycle perfectly. Let's see that this is kind of in the way. Move it down like that. Should be better. Now let's see. We need to have carrots to increase the speed further. And to increase the yellow grass, we need 500 logs, or wood, or whatever it's called. And to expand, we need carrots. And variables, we need carrots. Ooh, timing, pumpkins. Set speed, we need 500 of something gold, perhaps. So, carrots. Till the soil and plant carrots. Okay. Before you can plant carrots with plant and entities.carrot, you have to till the soil. This will change the ground to grounds.soil. To till the soil, simply call till. Calling till again will change it back to grounds.grasslands. Planting carrot costs wood and hay. So it costs to plant carrots. That's interesting. These items will be automatically removed when calling plant entities.carrot. You can see the cost of any plant on its own page. Oh, that's why you need the checks to see how many of each items you have. So you can check if you have enough items to actually plant the carrots. I suppose... Wait, it said... Cost wood and hay... Is the cost of any plant on its own page. So it costs one of each. Then it should be perfect to have hay here and then have carrots on those three. Maybe. Or it depends on how long it takes to actually farm the carrots. That's a good starting point, I suppose. For more related information is carrots. So it's this one, okay. So can do elif. Get, or simply like that, get was x. If that is 1, then we do the hay farming. And else. Then we do the planting of the carrots. So if get ground type. Oops. If get ground type. And that's equal to grounds.grasslands. Then we want to till and want to plant the... Oh wait. No. We need to check first. If can harvest. Then harvest. No matter what, we want to harvest the tiles. Even if it's simply hay. Then we want to check if it's grassland. And if it is, then we want to till it. And then we want to plant the entities .carrot. And we're not gonna worry about checking for how many of the wood and hay we got left for now. We might run into an error if we let it run too long. But it should be fine like this, I think. Let's try it. So we plant the bushes, form them. Okay, get ground. Oh, get ground type. We call it as a function, obviously. Try again. And now we're planting carrots. Nice. And they managed to... Wait. They almost managed to grow in time, so there's some sort of overlap. But this also means we will get more. We will get a surplus of wood and hay when it's like this. So it isn't all bad. It goes really fast. We can increase the yield of carrots. Ooh, trees. Watering. Water plants to make them grow faster. Interesting. Variables. Expanding the farm is more interesting. I'm just gonna take a short bathroom break, so I'll be back soon. And I'm back. I got another cup of tea as well. So... Ooh, already almost 250 carrots. Nice. And we're still making a profit on the wood and the hay. But now it's time, I think, to expand the farm. This also clears the farm. I suppose that means I need to do like that. So this should still work, right? Yes, but I need to increase this one to 3 now. Now it should still work on these 3. Oh, and yeah, it skips. It's worth like checking that you have enough wood and stuff when you have more carrots than the resources. But should I do trees as well, maybe? Water the plants to make them grow faster. That could be useful. But I feel like trees... I want the trees. Trees are a better way to get wood than bushes. They give 5 wood each, like bushes. They can be planted on grass or soil. Trees like to have some space, and planting them right next to each other will slow down their growth. The growing time is doubled for each tree that is on a tile directly to the northeast, west or south of it. So if you plant trees on every tile, they will take 2 times 2 times 2 times 2, 16 times longer to grow. So wait, show, is this like a spoiler or... yeah, maybe that's a spoiler, I don't know. What about simply planting 1 tree in each corner? That should make it relatively fast, right? But it will also require me to hard code some sort of check on each loop. And if it would have to be in here. In the beginning, so if get was y equals 0. Can't forget the parentheses. Call the function. So if we're on the first position, then we can if can harvest or should I put this in here? Because then it will harvest and then I can check the Y position and plant depending on the Y position. That has to be a better way to do it. So remove this and then I check if can harvest, then we do harvest. And then we check if it's Y or can I do it like this? Equals 3. Then we want to plant entities dot tree else would that work? Should work, right? On those two. Wait, we planted one tree, but not on. Now we planted a tree. That is kind of strange, right? I probably need to do this step by step. So if we can't harvest, but we do clear it first, don't we? Oh wait, so we plant. When we do clear, it clears everything, so we can't harvest it. That iteration. That makes sense. So since this isn't ready to be harvested yet, then we plant a bush instead of planting a tree. But why are we even checking for this? There's no reason to check for this, is there? Can't we simply... Wait, isn't there a timer or something like that? Get time. And it costs pumpkins. I want to do it like a tiny delay so the drone stays until all the grass has grown and then it gets started. Just for the visual kind of sake. Because now when you start it, it skips it first two spots. But we don't need this. I don't know why. I don't even know why I did this. There should be no reason for it. When you till, it makes sense. But we also need to do... So... If... Position Y... Not that. And... We should also do... Ooh, wait a moment. I could do elif get plus x equals get world size. Is that a function? Yeah. Minus 1, right? I think so. So if we're on the last row, then we want to basically check if can harvest. Then we harvest. And if, suppose I can copy this one here. So if we're on this one or this one, then we plant a entities.tree else, or should I say, yeah, else if copy this one here. So we, if there's grassland, then we need to till it, and then we can plant entities.carrot. This should work, I think. So we plant the tree, and we get the hay and plant the carrots, and now we should plant a tree, and carrot and carrot and a tree. We don't get enough hay now though. Ooh, new hat unlocked. Nice. But I suppose this gives 5, this gives 1. To get 20 trees. It might be worth it to... Wait, we get 10... Okay, we get 10 grass, so we get more than enough for the carrots. Yeah. Can increase the yield of bushes and trees. Or we can get pumpkins. I want to get the pumpkins, since I want to check for the time. Nice. Pumpkins grow like carrots on tilled soil. Planting them costs carrots. When all the pumpkins in a square are fully grown, they will grow together to form a giant pumpkin. Unfortunately, pumpkins have 20% chance of dying once they are fully grown, so you will need to replant the dead ones if you want them to merge. Okay, when a pumpkin dies, it leaves behind a dead pumpkin that won't drop anything when harvested. Planting a new plant in its place automatically removes the dead pumpkin. So there is no need to harvest it. Okay. Can harvest always returns false on dead pumpkins. The yield of a giant pumpkin depends on the size of the pumpkin. A 1 times 1 pumpkin yields 1 pumpkins. 2 times 2 pumpkin yields 8 pumpkins instead of 4. Okay. It's a good idea to get at least a 6 times 6 size pumpkins to get the full multiplier. I mean 6 times 6 is larger than my whole farm. This means that even if you plant a pumpkin on every tile in a square, one of the pumpkins may die and prevent the mega pumpkin from growing. How much would it cost to increase my farm size? It isn't that expensive. It seems we're supposed to... Wait a moment. I need this, I really need the custom functions. So we get the variables first. Let's just read through this as well. Variables can be thought of as named containers that can hold a value. The equals operator is used to declare a variable and store a value in it. Variable underscore name equals value. The left hand side of the operator is the variable name. You can give it any name you want. The right hand side is an expression whose resulting value will be stored in the variable. Declare a variable name A and store the value 5 in it. Like that. And declare a variable name B and store the return value you can harvest in it. Do not confuse the equals operator with the equals operators, or whatever you want to call it. The double equals. The double equals operator checks whether the two values are equal and returns true or false. The equals operator assigns the value on the right to the name on the left. After a variable has been assigned, you can use it in the code to retrieve the value in the value it contains. So A equals 0 for I in range A, do a flip. Do a flip 5 times otherwise. The above loop is executed 5 times because A is set to 5. The I in the for loop is also a variable that is automatically assigned the current value of the sequence at each iteration of the loop. It doesn't have to be called I, you can give it any valid variable name. Variables also need you to do the same thing with a while loop. A equals 5, I equals 0, while I is less than A, do a flip, I equals I plus 1, so you add 1 to I. This does the same thing as the for loop above, we just have to increment I manually. Note that to increment I, we set it to be its own value plus 1. Changing the value of a variable based on its previous value is something very common. It can be abbreviated using these operators: plus equals, minus equals, times equals, divided equals, percentage equals. Percentage equals? Is that how you say it? I equals I plus 1 is the same as I am. Okay. Easy enough. Wait, what's this? Oh, it's the for loops. I don't need that hint. And now define your own functions. This is the good stuff. The good stuff to make sure that I don't have to like keep removing my old or wait, that maybe I don't actually need. Now that I think about it, this wasn't actually strictly needed. I could have just created a new code file and run it like this. Well, anyways, now I have the function, so let's use it. Use the def keyword to define a new function. Def arg1 or arg2 equals false, function call. You can use the call operator to call the function. Also see scopes to learn about local and global variables in functions. Introduction. You've already seen built-in functions like harvest. You can also define your own functions, which allows structuring your code in a modular way. It basically allows you to give a name to a block of code so you can call it from anywhere you want. Function different definitions. For example, you could define a function that moves the drone several times. Yeah. The def keyword signals that this is a function definition. Move and dir is the name of the function gets bound to. This can be any valid variable name and will be used to call the function. N and dir are parameters. They are variables that hold the values that are passed into the function. These values are also called arguments. You can add as many parameters to a function definition as you want. The colon comes the code. After the colon comes the code block that will run when the function is called. With the above definition, the following code then moves the drone 10 tiles north and 2 tiles west. When you see def function, you should really think of it as a variable assignment like this function. Like with all assignments, you can't use the variable because it was assigned. The def statement has to run before any function calls. This code will throw an error. Func def func pass. Because we call it before it's been defined, I guess. Return values. Use the return keyword to make a function return a value. For example, the following function defines the exclusive OR operation. The exclusive OR returns true if one value is true and the other one is false. And define XOR A and B, return A does not equal B, so we return true if A does not equal B, and we return false if A equals B. If XOR true false, do a flip. So we do a flip if we do this. Tuples allow returning multiple values. Default arguments. You can also assign default values that will be used if no arguments are passed. Def if A equals false, if A do a flip. Okay, and if we only call F, then an argument that has a default value cannot be followed by an argument that doesn't have a default value. Advanced function usage. Functions are values just like any other value, and the def statement just acts like an assignment statement, assigning the function to whatever name you give it. This allows doing things like this. Define the function f and define the function d, do a flip, return d. Ooh. Okay, interesting. What? Here f calls the function f, which defines and returns a new function d. The second parenthesis then executes the return function and performs a flip. Doing these sort of things is usually not a good idea because it's hard to see what's going on. Yeah, it is very hard to see what's going on. Functions that take other functions. Oh, new hat, carrot hat. Nice. Functions that take other functions as arguments let you get really creative. So define f g args for underscore in range, then g args. What? Oh, so we pass along a function and then we call the function with the arguments 10 times. Interesting. So we call the move function north 10 times. Use items not fertilizer 10 times or whatever. Yeah. Okay. But I suppose I don't need this one. So let's see. Could define a function then called what should we call it? Hmm. Carrot. Carrot farming, maybe. And then we can pass along all of this. Ooh. Inside of there. So while true, we can do carrot farming. We all can also do definition of the movement, so farming movement. And let's copy and paste this one. So we do cat farming and farming movement. And this should be equal to what we already did. And everything is working as it should. Neat. Okay. But then now we can also do a new function called pumpkin farming. Wait, is pumpkin is no, not pumpkin. Pumpkin. There we go. And if I'm not entirely the pumpkin farming, so everything we'd need to do is if can harvest. Oh wait, we don't want to harvest the pumpkins, do we? We want to plant the pumpkins. Let's simply do plant entities dot pumpkin. I want to see what this does. We don't like that. Oh, we can't plant. We need to till the soil first. Stupid. So if grounds dot no wait, if get ground type equals grounds dot grassland, then we want to till, and then we can plant. So now we're planting the pumpkins, and some of them died. So 20% risk of them dying. And they automatically replaced those ones. Oh. And now we have a mega pumpkin. And the question is how we're supposed to check if it's a mega pumpkin. I suppose we could check the position and then iterate through all of them. And check if they're all pumpkin and they're all grown and none are dead. then that should mean that the pumpkin is ready to be harvested. Should be able to do that underneath this one here. So if x, no wait, get position I'm not entirely sure because we will call this function each time. Wait, no, I think I have an idea. We need to have a variable that's outside of this function. Let's call it pumpkins. And we set that to 0. And then we need to check if can harvest. Or if not can harvest. Then we plant the pumpkin and we set the pumpkins to 0. Else we set the pumpkins to plus equals 1. And then we check if pumpkins is greater than or equal to what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, I'm feeling slow. 16. So if they're greater or equal to 16, they should never be able to get greater than 16, but then we harvest. I think. But you can't do that kind of operation. Wait, if can harvest equals false. So if we can't harvest, then we plant a pumpkin and we reset the pumpkin count to 0. If we can harvest, then we iterate by plus 1, and if we reach 16 pumpkins in total, then we harvest everything. Let's try it out. Oh. So try to read the variable pumpkins before a value was assigned to it. If you want to modify a global variable, you have to use the global keyword to write to the global scope. So I suppose we need to do global pumpkins. Like that. Right? Yes. And we harvested everything. And we got 64. Nice. It worked. So this should be the most efficient way I can imagine planting the pumpkins. Well, there's still the way I keep, or the way it keeps going, like this instead of going like that. But that's the farming movement, so I could simply fix the farming movement function, this one, and it should increase the efficiency. And I should also, now that I think about it... Oh no, stop exactly when they finished. I should also do is get world size times get world size. This should be exactly the same, so 16, 4 times 4. So this code will still work even though we might increase the available farmland. Let's try it. There's no error, so... You know, it counts everything, and it worked. Nice. What do we need? Get time with, okay, 1k. 1k pumpkins. What about the expansion? Wait. Didn't I expand? I didn't expand the farm, did I? No, and expand it again. And now the pumpkin farm should still work, even if it's much larger. Oh wait, the movement. I should do get world size -1, right? -1. Yeah. Oh wait, is this the max size of the pumpkin? No, it can't be. Or is there a limit on the maximum size? If there is, then I suppose it will stop working now. It still works. Okay, nice. But wasn't there like a fire type size 125 pumpkins? So wait, if so the exponential limit gets removed, but it's still worth it to create a massive pumpkin. Okay. But I want to fix the movement. I feel like but I need to think for a bit. How do I want to do this? We have ground zone. So we start by going up, and then when we reach the top position, then we should, instead of going one more so that we go down and restart, then we should instead go to the right, always, or east, more like always go to the east. So maybe we should check, like, if we move east, then we switch the... Ooh, that might be a good idea. To have like a variable that gets switched, like a boolean if moving north. That we can check against. But I'd need to... Or wait, can you... You can work on another code while it's farming, can't you? Ooh, and now we can also get the time function. Timing. If you really want to optimize your methods, you need to understand how time is measured in this game. This unlock is all about that. New functions. There are two useful functions to measure how long things take. Get time returns the time in seconds since the start of the game. Get tick count returns the number of ticks performed since the start of execution. These two functions, as well as quick print, are completely free. Even the call operation is free for them. Runtime details, heads up. This is not how performance works in the real world. These are just rules made up for this game to have a consistent and understandable time model. You will probably only care about this if you want to hyper optimize your code. Or if you want to make it a bit pretty. Like, if we were to go back to the carrot farming. And then we can do a if. Wait. What was the time? Get time. So if get time is greater or equals to 1 second, or should I say is less than or equal to 1 second, or simply less than 1 second, it's better, then continue. And continue means to simply repeat it, so it will be stuck in this loop until 1 second has passed, I think. So then we should be able to, wait, no, there must be, oh, a colon, yeah. So now we should have a 1 second delay at the beginning. Wait. Immediately continue with the next loop iteration. Wait a moment. We don't want to break the loop, do we? Breaking the loop will end the... Maybe I should start by print get time. Let's see what it says. Oh, since start of the game, so it's not since start of the of this run. That isn't as useful. I want to know. Get tick count is probably better. Get tick count. So now we have 204. Okay, wait. We got a lot of ticks though. A lot of ticks. Let's do no farming movement or anything. Simply the tick count. Oh wait, here we have more information. The basic unit time for code execution is called a tick. Without speed, accuracy, and power, the execution proceeds at rate of 400 ticks per second. Without speed upgrades. Okay. So I suppose get tick count. If get tick count is less than 1200, then we want to continue. Otherwise we want to, oh, not that one. Otherwise we want to farm. Probably. Yeah. So that was set. Maybe we can even do 800. Yeah. So now we have a small delay. We can even call this a function. Define a start delay. So paste this one. And then we can do start delay, I think. No. Mm. No, we can't do this since this is an outside loop. I suppose we could do... I think. And then get stuck in this loop for 800 ticks before we continue here. But then that would mean... Then we have to do else break. Right? I think. Otherwise we had to break the loop. So even though it technically runs the start delay, we instantly break. But this might actually be slowing down our processing of the crops. Oh yeah, why? Wait a second. This isn't good. We should run start delay here. Start delay. And then we run the actual program. We should define this as the main. And then have the main function with this here. Oh, and the while true also. Like that. And then we call the main. So we have the start delay and then the main. And now we don't go through this additional code each time. And we save some processing power and some speed. But the carrot farming isn't working as it should now. It's really not working as it should. So let's go and fix the carrot farming. So we check if the position y is equals to 3, but we shouldn't check that. We should check get world size. -1, I think. Let's try and run this one. No. Get world size as a function, of course. And now we should get a tree there. Nice. And the same goes here. So now we plant a tree in each corner. There might be a more efficient way of doing it, but could increase the speed as well. And increase the tree yield as well, and on the bushes. Costs a lot of hay, but it's worth it, I think. Then we can also increase the carrot yield a lot. And we can't increase the pumpkin yield without more carrots. So then I guess it's good then that we have a increased yield of trees, and on the hay, the grass. Now we're 400% and 400%. Because now we can have even more. Wait, even more of these carrots. But it takes... wait, it takes more... Does it say... yeah, no, it's increased in cost now. Okay. So we're actually... are we losing wood? No, we're actually gaining a little bit of wood. We're definitely losing hay though. This is way too little hay, I think. It was 1,450 hay. And we already went below that. So we either need to increase how much hay we get, or increase the yellow grass, or have more grass. I suppose we could... so if LF gets position 1, or LF get position 2, right? Now we get 2 of them. Now we should go into the positive. Hopefully. So 1,502. Yeah. Nice. Okay. I didn't read the rest of this. So, in general operations that combine two values such as plus, minus, oh, what's the name of this one? Let's say the asterisk, the slash, the double slash, or the... do you simply call it the percentage sign? I'm confusing it with ampersand, but ampersand is it's the and symbol, I think. Anyway, and or take one tick to run. But in general operations that combine two values. Okay. Take one tick to run. Single value minus and not are free. And if branch also takes one tick to run, in addition to the time it takes to evaluate the condition expression. Function calls and variable reads and written and writes are free, but function definitions take 1 tick. So when you define the function for the first time, then it takes 1 tick, but calling the functions like this isn't inefficient. Import statements are free. Accessing an imported module with the dot operator is free. Oh, so we could do... Wait a moment. Could we do like... pumpkin... what should we call it? Pumpkin season, maybe. If we call it that, and could we then copy this one? And then we can actually edit the pumpkin season script while it's farming the carrots. That's nice. So we aren't stuck doing nothing while waiting for, or while doing some planning for another farming. So wait a moment. Let's remove. Oh wait, we also need the pumpkins. Set that to 0 as well. Then we could remove this, and in the beginning we could import pumpkin season. And instead of calling pumpkin.farming, we could do pumpkin season.pumpkin farming, I think. So this is the way to call pumpkin farming, probably. So if we run the main, now it's, no, okay. We must unlock import, okay, that makes sense. Import costs 80 carrots. Worth it. Putting all your code in a single file quickly becomes unmanageable. Import statements allow you to import functions and global variables from another file. How it works in one screenshot. So, where the module 1, import module 2, not x plus 1, okay. So that should be pretty self-explanatory. And now it should work. And now it's planting pumpkins. Nice. Then we can also create another file here called, let's call this one carrot season. And we can get all the carrot farming. Oh, I didn't mean to cut it out. I meant to copy it out. But we can import it like import carrot season. And then we can have carrot season dot carrot farming. So we can remove that one. And now when we will run from the carrot season. Nice. So now we could work on the pumpkin season if we wanted to. while this is running. Oh yeah, I wanted to work on the movement as well. The movement is really broken. So I suppose we could do that in a module of its own. Call this drone movement. Or maybe drone movement 1. We might want different drone movements. We'll have to pause this as well. So I have the function called farming movement. So this is this is one, and then we have the import drone movement 1, and then we do drone movement 1 dot farming movement, and then we can remove this one as well. And while we're at it, we might as well do a for the start script to clean it up so it looks even better. Let's call it the I don't know. Daybreak delay, maybe. I don't know. Or simply daybreak, maybe. Daybreak. And then we can remove this one. Import daybreak. I want to put this one at the very top. And then we do daybreak.start delay. And we should be able to put this one in the main function as well, above this one. Like so. Now we have a neat little main function here. And we have this one, the start delay, which we can put wherever, out of the way. And now we can do carrot farming. Wait, why isn't... Oh, the start delay is too short now that we increase the speed. Or wait. No. That isn't the issue, is it? It almost feels like the whole program is slowing down if I do it like that. Oh, it's because we don't we aren't calling the clear function, so we should call the clear function in the daybreak instead. So like that. And now we go back and we can shorten this back to what, 800, I think. And now it works as it should. What does it say here? Import statements are free. Oh, that was the part that made me do all of this. Accessing and import a module with the dot operator is free if a function or module has been passed via argument or variable assignments. Using it will cost 1 tick instead of 0. If a function or module has been passed by arguments, okay, I don't do that. For and while loops take 1 tick to start, but the iterations are free. Not counting the time to evaluate the condition/sequence expressions. Return, break and continue are all free. Pass takes 1 tick, so it can be used to create precise delays. Indexing into a data structure takes 1 tick for the index operator, and in the case of a dictionary or set, additional ticks depend on the size of the key. Okay, the number of ticks that built-in functions take to execute is documented in the documentation of each function on an individual basis. How do you check that? Can you like press this one somehow, get it up? No, it doesn't say. But I've been farming for a while now. There was something I was supposed to buy. I could expand the farm again. Was it a yield of grass? Maybe the yield of pumpkins? I will need a lot of pumpkins if I'm about to farm cactuses. Water the plants to make them grow faster. Fertilizer. Grow plants instantly. Sunflowers. Mazes. A maze with a treasure in the middle. Okay, so that's how you get the gold. Ooh, more drones. Interesting. Wait, 1 billion hay. Oh man. Dictionaries, leaderboard. Debug 2. Functions to temporarily slow down execution and make the farm smaller. Well, I can't buy it anyways. Could increase the speed. Feel like why not? Could increase the speed once more. I feel like. Or I could expand the farm. I feel like I want to fix the movement of the drone before I expand the farm further. Let's do the last drone speed. Now it's 5 out of 5, so it's the fastest it can go. Ooh, that's really fast. Okay, so we have drone movement 1. Let's do a drone movement, movement 2. And let's, we need to move it over here perhaps. So we define a function called farming movement, and if get plus y, so if we're below the world size, so if we're on the last, as long as we're not on the last square, then we move. I feel like we need a boolean, let's call it northbound. Set it to true. Should be one word, northbound, like that, I think. So okay, wait. So as long as we're not on the last segment here, I feel like the noise is getting a bit distracting. This is better. With the drone. Oh, it's the noise is louder when you're closer. I didn't think about that. I might want to lower the... Oh, it's the drone. The bird song stuff is pretty nice though. Is it supposed to be music? Because there is no music. There was a music in the beginning, like for 1 minute, then there was no music. Let's switch over to pumpkin season. Okay. So, as long as we're not on the top row, then let's see. As long as we're not on the top row, then we move somewhere. Otherwise, we move east. No, wait. Yes, east. We will always move east if we're on the top row. Oh wait, no, this is wrong. No, this is right. Except it isn't right. We also need to move east when we're on the first. Okay. So I think it's better to... Let's rethink this. Let's do get plus y. So if we're on 0 or get plus y equals get world size -1. So if we're either on the bottom or on the top, feel like we need to do another check here if get pos x equals zero, because we don't want to wait. So if we're on the bottom or the top, then we want to move east. But we don't want to do it on this square. We only want to do it on this and this and this and this and this and this. So we also need to check here again if get pos x equals, or should I say, is greater than 0. Then we move east. Oh wait, no, that won't work either. I suppose we could do elif statement. So if we do it like that and like that, so if we're on the bottom row and we're further right than the first square, then we move east. But if we're on the top row, then we move east no matter what. This should prevent us from moving east on the first square. And else, in other words, if we're not on the bottom or on the top square, then we need to check and again if wait, northbound false. So wait, no, true. Let's set it at the true. So if we get pos y equals 0, then northbound, we need to do global northbound. The northbound equals true. If we're on the bottom, then we want to go north. And if we're on the top, then northbound equals false, because then we'll want to go south. So if northbound move north, else move south. Right? Or am I stupid? This should work, I think. We check if we're on the bottom. If we're on the bottom, then northbound equals true. It's true, so we're somewhere in the middle. And if northbound, so if we want to go north, then we go north. Otherwise, we go south. And import drone movement 2. And then we do drone movement 2 for movement. And we try it out. Okay, so there's an error. If get pos y equals 0. If we're on the 0, northbound equals true. Oh, spot, probably. Okay, never mind. So let's do this step by step here. Go through all of them. We clear that. This one returns. Come on. Wait. It has to go through all of those. That's kind of annoying. No, I won't be able to. Oh. When did I drop frames? For how long have I been dropping frames? Oh, it's been a few minutes of issues. That's somewhat annoying. But my internet should get better in a few minutes, so... I'm just gonna let it form while I wait for my internet to get better. I'll be right back. Is the stream live again? It seems to be alive. Let's quickly check. It seems to be working now. It's annoying how the network keeps dying like that for a few minutes. It doesn't happen every day, but it happens like... I mean, I've been streaming not for a month, but something like that. If it's like 4 days a week or something like that, my internet simply dies for a few minutes. But let's ignore that and get on with it. I switched back to the farming method because of the error from this one. Okay. So why is this? Why is this? We check if the Y position is 0. If it is, we go north. Like that. If not, if we if not, we go north. If northbound, we go north. But if we're on the top level, the northbound is set to false. And we move east. Oh, so we get stuck here. We never go to this one when we got to this one here. So should we maybe always move? Maybe? Because now we only set it to northbound when we're on the bottom, and with the northbound falls when we're on the top. And we only move east when we're on the top or the bottom. But we will also always move north or south. So we should go like this, hopefully. Okay. Something funky is going on. That's not what I had in mind exactly. Kind of wanted to clear that. Okay. So, is it because we go both north and south on the same? Ooh, okay. So we should check as well. Like if move east. If we're moving east, which is if move east equals false. Oh wait, no, this one can be the parent of this one, or the outer nesting. So if we're moving, as long as we're not moving east, then we're going to go south. But won't that get us stuck in this loop again? Okay. Am I dropping frames again? I might have been dropping frames for a few seconds. Hmm. Hmm. I feel like I want the sound effects on again. When the drone. Hmm. 69. East here. That makes no sense, does it? It's somewhere in this start position. Maybe this one is messing it up? No. We're stuck in get pos Y. So if this is equals 0, then northbound equals true. But as long as pos X is greater than 0. Wait. What about greater than 1? This is X equals 1. Okay, so if it does not equal 0, let's remove this east mention here. Now the only east mention is this one here. Now the drones should be incapable of moving east. We're on the Y, 0. Am I going crazy? It feels like I'm going crazy. What happens if I comment out this one as well? I can't do that. I will need to comment out that one as well then. Okay. Oh, wait a second. It's this one, isn't it? I thought I was clever implementing like a check to see if we were moving east, but this one actually calls the move function and moves it. Moves the drone into the specific direction by 1 tile. If the drone moves over the edge of the farm, it wraps back to the side. Takes 200 ticks to execute the drone. Has moved one tick otherwise. Hmm. So it's... I can't check if we're moving east. I suppose I should implement some sort of function that makes sure that we can only move one step per movement somehow. So I suppose I could have a variable called moved equals false. So instead of doing that, we do it like this. Or wait, no, we do it like if moved equals false, then we check for the movement and do the movement. And when they move, we also set moved to true, as well as this one, moved equals true. Then we know that we've moved this round. Maybe. Let's try this. Well, we're back to this one. It's because we're stuck here. Isn't that we need to... Can't be that we need to set move to false afterwards? No, that makes no sense. I feel like I'm stuck on this part. And yeah, it's been a while. I feel like I want to take a break here for today. It's already been almost 3 hours. So yeah, but we farmed a lot of hay and wood, carrots and pumpkins and whatever. And there's still a lot left to do before we get all the unlocks and all the items and all the stuff, but yeah, I am satisfied with the progress. It's been kind of satisfying. Yeah, man. It was a fun game. So yeah, thank you so much for watching, and I'll see you in the next one. Cheers!